Okay, so I think this is going to work. What I'm going to do today is I'm going to do some calculations, some acid-base calculations that go hand in hand with Module 6, which we just finished, as well as Module 7. We're sort of building, you may have noticed that. We're building on Module 6 as we go to Module 7. Module 6 kind of built on Module 5. We're going to see that now for the next couple of modules. Now what I'm going to do is I'm going to be picking some compounds that are from our tables, and I'm going to be making up the numbers as we go. So I've got my calculator here. I'm going to be doing the calculations. As we do this, you be sure and catch any mistakes that I make and share them with the group. And you can do the calculations with me. So for example, we see a lot of questions in Module 6 and in Module 7 that start with, what is the pH of? And in order to answer this question, you have to identify what the chemical species is. So the first thing we're going to go through is we're going to go through, before we do the calculation, sort of a flow chart way to identify what's going on. And that's going to tell us what are our next steps. So what is the pH of? When you see the chemical compound's name, and usually it is in terms of the names, you will notice that what is the pH of will now list either an acid or a base or a salt. So you have to identify, is the compound they're asking about an acid? Is it a base? Is it a salt? Here's how you do that. Is it an acid? If the name of the compound is blah blah acid, you're looking at an acid. That's the only kind of acid that we see on this first round. It has to have the name blah blah acid. How do you identify if the compound is a base? Well, in Module 5, we learned, and I'm going to look just because I'm afraid I'm saying the wrong module name, number 4 or 5. In Module 6, we learned about strong acids and strong bases, and all of our strong bases are blah blah hydroxide. They are the metal hydroxides. We learned how to name them back in Gen Chem 1, and they're the soluble ones. We learned about what's soluble and insoluble back in Gen Chem 1. So typically these are the group 1A metal hydroxides. There are a couple of group 2A metal hydroxides, but they're the sodium hydroxide, potassium hydroxide, calcium hydroxide. They're the metal hydroxides that are soluble. Those are bases. In addition, we learned in Module 7, at Module 6 and Module 7, as we started looking at weak bases, ammonia is a weak base. You should be able to recognize ammonia is a weak base. Then in addition to that, as we started looking at tables of constants for weak bases, KBs, we see a lot with the pattern blah blah amine. Those are the ammonia type bases. They act a lot like ammonia acts. And so if it is, what is the pH of blah blah amine, you're looking at a weak base. So that's how you identify if it's a base. How do you identify if it's a salt? Well, a salt is a fancy name for, and it's not that fancy, ionic compound. So if you're looking at a salt, you're looking at an ionic compound. And we learned how to name ionic compounds back in Chem 1. Ionic compounds have the name of the cation and then the anion. So there are two words to the name. Neither one is acid. So sodium chloride is an ionic compound. It's a salt because it's made up of the ion, sodium ion and the chloride ion. Now, sodium hydroxide is also a salt. It's an ionic compound, but we've already identified it as a base because it's a metal hydroxide. So that's the first thing you identify. Is the compound that this question is talking about, is it an acid, a base, or a salt? So if you decide that the compound is an acid, the next thing you have to ask yourself is this a strong acid or is this a weak acid? Well, how do you do that? There are 6 or 7, depending on which list you look at, strong acids. The rest of them are weak. So you must memorize or list out and have on your piece of paper handy while you're taking your quizzes and your exam. The strong acids, that's how you identify them. They're on that list. I used to tell folks you had to memorize them. You can have the list handy. If it's not a strong acid, it's a weak acid, period. All right. How do I identify or once I identify I've got a base, what do I do next? I identify if it's strong or weak. Well, how do I identify if it's strong or weak? The only strong acids, as indicated back in Module 6, are those metal hydroxides that are soluble. There's a list of them in the textbook. Have that list handy, have it memorized, however you do it. Those are your strong bases. If it's not a strong base, it's a weak base. Another hint as to whether you've got a weak acid or a weak base as opposed to strong is if there's an equilibrium constant involved. You're looking at a weak one. Strong acids and strong bases don't have equilibrium constants. Their equilibrium constants are so huge, they're such big numbers, greater than 1, that we don't consider them equilibrium reactions. But the weak acids and weak bases, those have equilibriums. Now, if you identify you have a salt, you do have to ask yourself 2 questions. One is this salt soluble? Does it dissolve in water, or is it insoluble? Now, in Module 6 and 7, we will only have soluble salts. We will not have insoluble salts until we get to Module 8. So for now, hold that for now. In Module 8, we'll come back and start talking about, well, what if it's insoluble? In Module 6 and 7, if you've got a salt mentioned in a what is the pH of, it is a soluble salt. All right, I'm going to stop the flowchart there. I'm going to cut off this video, do it in pieces just to make sure it's working, and then I'll come back with the next video.